If your communication models drops connection intermittently or your softball boots unreliably, do not overlook the wire fill and pad surface condition when checking BGA solder joints. When high-density BGA use wire impact, 4 key details can affect final assembly reliability. Here is how Fasten controls them. First, manufacturability review. We review the BGA ball pitch, wire placement, ball thickness, and hole diameter to confirm whether wire impact is appropriate for that area and which filling process is required. Second, choosing the right filling process. Based on the wire structure and reliability requirements, we select either resin film with copper cap plating or an electrolytic plant copper-filled process. The goal is not simple to plug the wire, it's to minimize internal walls and reduce the risk solder wind into the wire during reflow. Third, controlling pad planarity. After wire filling, if the pad surface is recessed or re-raised, BGA solder ball may not contact away the ball evenly. This can lead to the inconsistent solder joints and high risk in hidden BGA connections. For wire impacts with resin filling and copper cap plating, Fasten planarize the surface after resin curving, remove excess resin, and control the pad conditions. Then we complete metallization and cap plating to form a flat, continuously solderable pad surface. First, inspection the critical features. We use the microsection analysis to verify fill completeness and internal structure. Then inspect the finished pad surface condition. This helps reduce uncertainty after BGA assembly. With wire impact, every step from the wire filling to pad planarization can affect BGA soldering yield and long-term product reliability.